Good day, everyone. Today we're going to be talking about Meraki BGP. Currently, this is still in beta code, but you can participate in the beta code process by contacting your Meraki representative and having them enable that for your organization. It is only available right now in concentrator mode or VPN pass-through mode. One of the big takeaways here is the route advertisement behavior. It's very different from the traditional Cisco world, and there's some catches and gotchas that we'll discuss and that you need to be aware of if you were to implement this in your environment. The current documentation for this is rather thorough, and you're welcome to review that. We won't go over it here. We'll just get into the lab environment and see how it's actually working. As you can see here, we have a lab environment with two MX600s that are in an HA pair, and they are currently BGP peered over to a test of, or a VSS 6500 core for the Ebgp peer relationship. Well, let's discuss here how we enable this. Site-to-site VPN must be in hub mode. Okay. In the BGP settings, when they are enabled for your organization, they will come disabled by default. As we enable that, we have to define an organization-wide autonomous system number. So if you're implementing this in a lab or in a production environment, be sure that you choose an autonomous system number that is unique and not shared by anyone else. We then define the BGP peer, the Ebgp peer, and the unique remote autonomous system number associated with that. If we were to define the autonomous system number for the peering relationship the same as the organization-wide setting on the Meraki side, that would be considered an iBGP relationship, and it will not work. It is designed to be eBGP from the head ends to your core. A couple of other things. As the field sites are creating VPN tunnels to multiple head ends, the concentrator priority here will define which hub is used to route traffic from and to the remote site. Okay, so that's something to be aware of. We have some access list rules down here, but that's out of the scope of this video. So let's review this. Where's my picture? So here is a high-level design overview of iBGP and field relationships to the head end and eBGP peering and advertisements into a core data center setup. In the lab environment here, we have multi-protocol BGP, so we're using VRFs, BGP redistribution. So your environment may not be as complicated as that. If that's the case, don't be overwhelmed by that. This is just our testing environment that we are using. But let's get an overview of what's going on here. You define your field sites, and every site will have some type of unique IP addressing that you would like to traverse your VPN tunnel. When you turn on the site-to-site VPN settings, you define what subnets are allowed over VPN. The VPN spoke to hub advertises those zones. Between the head ends and the field, there is an iBGP full mesh relationship. Each field site builds a tunnel to the head ends and advertises its remote subnets to those head ends. The head ends also share routing information between the two for full mesh iBGP. This autonomous system number 65530 that we've defined between the head ends is only significant to your Meraki organization. The eBGP relationship between the core and your head ends is defined by the BGP autonomous system number on the core here, and that's where we defined the eBGP and the peering IP address. Okay. Now we peer into the eBGP core onto a specific VLAN that the Meraki head ends are sitting on. We're also filtering the routes that are being advertised from the field. Since we know what routes are going to be coming in, we can specify a broad range of IP addresses, such as a 10/8, some RFC 1918 space that is significant to your organization or for testing. Reason why you want to filter is because we don't want someone out in the field having misconfigured a Meraki firewall and then is being naughty and advertising something that isn't local to that site or actually conflicts with something in your data center. So we just restrict that at the BGP peering relationship here. Now, the routes that are taken from the Ebgp peering relationship, we are redistributing into multiple VRFs. Why that's important for us is because we want support groups and for remote testing and reachability of, say, PCs, computers, printers in the field to be reachable from our core here for support purposes. Okay, so why is IBGP and EBGP here so significant to the Meraki organization? Well, technically with Cisco defined Ebgp peering relationships, you can say advertise a, let's say a 10/8 route to the field from my core here. So we can do a default originate, or we can say let's do a summary and advertise that out to the field so that field sites then know how to reach subnets back in your data center or your core or whatever campus subnets you have defined. We, in this scenario, cannot define a 10/8 to be distributed to the field. Why? Because, well, these field sites may have a consumer-grade internet service provider such as AT&T, Comcast, CenturyLink. Some of those modems actually hand out a 10/8 IP address on the WAN interface. Now, if you had a 10/8 on the WAN interface from a modem for internet reachability, and you're also injecting a 10/8 route over the VPN tunnel, these two will conflict, and the VPN tunnel will not work. It will just it will mark that as a conflict, and it will say the VPN tunnel is down, and that's actually an error that gets displayed in your Meraki organization when you're looking at a field site. So to prevent that, I do not advertise a 10/8 to my field sites. I actually advertise only specific subnets that I want these field sites to be able to reach. And we'll look at that here. The reason for this is we have support organization IP addresses that are in this block here, and application specific, wireless controller specific, and then VPN. And we want field sites to be able to be reachable from those IP addresses. So defining local networks here under the VPN settings of your hub, okay, those get defined here, and VPN site-to-site specific routes are advertised to the field sites, and those will actually show up in the route table of the appliance for your field site. So looking at a field site configuration, we have it configured as a spoke, and we have two VPN head ends, but the priority is currently hub A, and that's also defined down lower. We have VPN settings for local networks, and these subnets are locally defined on the box itself, or on the security appliance, excuse me. We say, yes, we want these subnets to use VPN. Are we going to translate that? For VPN subnet translation, yes, we're translating this 192.168 RFC 1918 space to a routable IP address for specific services. And we'll cover this in a different video. But the facility zone here is actually a 10 dot routable space. We don't want to translate it, but we want it to be usable over the VPN tunnel so it's reachable. As I said earlier, here is the route table from the field site. You can see the VPN site-to-site VPN subnets that are being advertised from the head end itself. Okay, so these routes are actually being injected into the field site security appliance routing table. So now as we look at the core BGP configuration, we start to understand the Ebgp peering relationship. We have our BGP autonomous system number, which we saw was defined as the Ebgp peering relationship. Since we use multi-protocol BGP here, we're actually peering into a specific VRF, we're allowing redistribution of connected and static routes, but then we're defining the Ebgp Remote Autonomous System ID and the peer IP address. We're allowing soft reconfiguration, and we're doing some filtering here with route maps and prefix lists. And we're defining that for both VPN headends in an HA pair. Why do I have this aggregate address here? Well, we have field sites that will go online and offline, online, back and forth, up and down, all day long. And I don't want to have BGP send an advertisement or an update every time a route is inserted or removed. Basically, I'm saying, per the BGP autonomous system, he owns this IP space. And that's all anybody needs to know about. The box itself that this is defined on, he will insert and remove the routes, but he won't have to send an update to his other BGP peers every time a field site goes up or down. And as I said, we're doing some prefix list filtering to prevent people from being naughty, such as inserting a default route. I am preventing local subnets from being defined. A 10/8, I don't want the headends to say, hey, for every 10/8, for the entire RFC 1910 space, come to me. No, we don't want that, so we deny that. And then we do allow, here at the end, our 172.23/16 IP space and our 10 dots. So any sites that have this IP addressing defined, those routes will be allowed to be injected. Okay, so we'll come over here to our core setup, and to verify our Ebgp relationship for we can see our BGP peers and the number of prefixes that are being advertised from them. But we also can look at the number of routes that are being received, or what specific routes are being received, and the number of prefixes. So as we can see here, looking at the received routes, we have all of the relevant 10 dot space, and we have all of the relevant 172 space that's being used for VPN NAT subnet translation. So that's the overview of Meraki BGP in its beta code. It is working. There's still a couple of bugs that Meraki is working on, but for the most part it is up and functional, and we have a very stable environment here. Thanks for watching, and if you have any comments or questions, please post those below. Thanks.